Okay, so here we go. If you have highlighters, you may want to get them out, but less than 94, adding like terms. Okay, now look guys, why doesn't it say subtracting? Because adding can be converted to subtracting if you add a negative. Okay, so really what the word you're going to think when you see this, what you do with like terms, we're going to be combining. Okay, and combining is like an umbrella word. You add or subtract based on what is present. Okay, but we're going to be combining like terms.
And subtraction? How does that?
Combining means add or subtract based on what's present. Okay.
You wouldn't say like.
You combine a positive with a negative. That's the same thing as subtracting.
If you combine 6 and 7, it's not subtracting.
Well, no, that's the adding part of it, right? All right. So the book takes one approach. Okay, the book takes one approach. I'm going to start off with another. Okay. So let's say I had. Something like this. And you're going to think, that is so weird, man. Okay? That is so weird. Why are you doing that?
Numbers.
Huh?
Where are the numbers?
Alright, I'm not putting numbers in it yet, okay? I'm not going to do numbers. I'm going to just jump from this straight to variables, okay? Because you don't need to know how to combine numbers. You've been doing that for almost a decade. Okay? But if you were going to write a simple statement that summed up what was present there, how would you say it in words?
Square 2 triangle 3 plus triangle.
Okay, say it in like more plain English, Quentin.
2 squares, 3 triangles.
2 squares and 3 triangles. We could say 2 squares plus 3 triangles. Okay, that seems a little weird. I know. Some of you are like, why is it doing it this way? So I have 2 total squares, and we assume those squares are like alike. Okay? So I could write that there are 2 squares, and I can say that there are 3 triangles. Okay? Can I combine it any further? No, because a square and a triangle are 2 different shapes. Those are going to be unlike terms.
You make it a pentagon.
Don't get crazy. Okay? So that is the essence of what we're going to be talking about in this lesson is, hey, the things that are alike are going to be combined into consolidated or condensed terms.
Remember when we found the area of triangles?
Yeah. Sure. I do. Okay? So let's change it up a little bit. So this is very, very basic, very elementary. Yeah, not that. All right. So let's change it up. Let's say that we have 2 of these here, minus 3 of those. We'll stick with the shapes for the time being.
The game is moving.
Yeah.
All right. Well,
Moving.
I don't know. That must not be a tighten thing. Okay. Oops, can't see anything now, bud. All right. Maybe it'll. Okay. Focus. All right. So if we were going to combine the shapes that are alike, how would that work?
2 triangles.
Do what?
2 squares and 2 triangles.
No.
Oh, wait. You add the 2 and the 5 and the 3 and the 6.
So I have 2 triangles and positive 5 more triangles for a total of 7 triangles. I have negative 3 squares and negative 6 squares. So I'm going to take 3 and 6 away. That's negative 9 squares. Okay? Now, why do you think I'm doing it this way with squares and rectangles instead of letters?
Make it easier.
It's easier, at least for shape recognition, to know that a triangle and a square are different things. Okay? They're unlike shapes.
Wait, what is triangle?
We don't know yet, okay? We don't know yet. It's important to be okay with an unknown value, otherwise known as a variable. Yes?
Didn't you say we were going to have another test?
I did, but for the most part, everybody did well enough that I don't think they'd want to.
Yes. No. Do we got
There will be some extra credit opportunity.
Do we have some special group before? In the grade test?
I really need it.
Wouldn't that be today?
It's not that type of test.
The end of your test?
It's not that type.
It's just like a regular test?
No, it's a big one, but it's not.
There's more bubbles in the normal end of your test.
The
Taking the fifth grade.
The pressure's not there, Anna. I'll explain later. Okay, so look, guys. Shh. Here's what I'm going to do. I want you to pay attention here. I'm going to change example 2 slightly.
Wait, you just changed the square and the triangle.
Now I don't have shapes.
Oh,
Yeah, you just changed the variable.
Made it what?
It made it look harder.
Does it? Well, let's use our colors for everything that has an X. I'm going to highlight in yellow.
What if I don't have colors at home?
Everything that has a Y, I'm going to highlight in pink. And you notice I kept the sign that was in front of it. What does that sign do for me? That helps me know.
Negative or positive?
What does that help me know how to combine them? How to combine them, whether it's addition or subtraction.
Like, why did you say combine though?
Because combine is the umbrella word for add or subtract based on what sign is there. That's why. Yeah. So, what are we going to do? Well, I have a 2x and a positive 5x to combine. This 2x is understood to have what sign in front of it? Plus.
Positive.
But it's not going to be written because we don't do that. Okay?
Why don't you do that? Like, it makes no sense. Like, the
It's-
person given math is just like, oh, we're just not going to put a positive sign here because they'll automatically know.
Yeah.
Like, what have you done? What have
Well, I'm telling you, so now you know. 2x and 5x are both positive and therefore combine to make a 7x. And then negative 3y and negative 6y are both negative and they'll combine to make a minus 9y.
What if like, you didn't know? Like, you don't tell me?
Well, I wouldn't be a teacher then, I don't think.
Like, what if the original teacher did it? And the only guy, the person who knows the data is not.
Luke, that's a wormhole that you're going to go down forever. Just take my word for it and let's move on, okay? Example 4.
It's confusing.
That example 4. All right, so was that really much harder than example 2?
No, it was the same.
If I had started with that, maybe, but
No, it looks harder because you can obviously see the triangle. You can't really obviously see the X's. I'm so great. That's even more confusing.
okay.
No, I don't.
So one trick, if you don't have colors, like Luke said, is that you can put shapes for different terms. So what we'd say, okay, for the constants, what does constant mean? A number without a variable. It's just a number, right? I could circle all of those. So I'd circle that one, and that one. And that would help me know that, oh, those are all like terms because they're constants, and therefore we can combine them. Question?
Is X considered a shape?
No.
Wait, but it technically is.
Okay. Just go with me. So I have 5, 9, and 11, but the 9 is positive, the 5 is positive, the 11 is negative. So I'm going to think 5 plus 9, 14, minus 11. 3. I have combined the constants.
I'm still confused. I never know which one's. Wait.
A constant is just a number without a variable.
But
It's simple.
how do I know what the variable is not? But I could think that
The variable is a letter.
like it might be multiplication symbol too.
I'll try to be obvious whenever I give you that, okay? So the next thing we could do, instead of putting a circle around the x's, I could put a square or a four-sided figure of some kind.
Yes, because squares are shapes. Like I could think.
So now I know that those are the ones I'm going to combine with each other. Okay? Negative x, which is the same thing as negative 1x, plus 4x. So what's that?
Positive
3x, positive 3x, take away 2x.
1.
So it's 1x, or just x, but what do I put there? Do I put add or subtract? Why add, Quentin?
Because I have no idea.
Because the result was positive. Negative 1 plus 4 is 3. 3 minus 2 is positive 1. Since it's positive, I have to put it plus sign there.
But, like, just because the result's positive, why does that mean you have to add it?
Because that's what combine encompasses.
But I don't get it.
Why does that mean you have to add them if they're positive?
Uh-huh.
Okay, let me rewrite this expression and see if it makes sense then, Luke, okay? 5 plus 9 minus 11 minus x plus 4x minus 2x. Now, why am I able to do this? Why can I change the order? Because of the commutative property of addition. Well, wait a second. I don't just see addition.
You just moved the numbers around. It doesn't make any more sense.
I'm not done yet. Okay? We're allowed to change the order as long as we maintain the signs that are there. That's a commutative property. But I'll take it one step further. 5 plus 9 plus negative 11 plus negative x plus 4x plus negative 2x.
That makes it even harder. That doesn't make it easy.
Well, let me get my point across, okay? Everything is, you're being asked to combine everything. That's the purpose of this expression. So, 5 plus 9, we did that already. That was 14 plus negative 11. You say, well, that's the same thing as 14 minus 11. But you can write everything with a plus sign. And that is why combining is such a powerful word. Well, 2 plus signs wouldn't really be meaningful.
But you could do it, right?
You could, but it wouldn't change anything. It would be the same thing as just a single plus sign.
Can you put infinite plus signs?
Let's keep, I'm not going to finish if you keep asking those questions, Luke.
Well, like, can you? Is it possible?
No, because it's infinite.
But, like, can you put, like, 50,000?
If you wanted to. So, I've got 14 here minus 11, or 14 plus negative 11, that's still 3. Now, you notice, if I wrote everything with a plus sign, my goal here was to explain to Luke and anyone else wondering, why do you put a plus sign in between the results? Because that's what was there from the beginning. You were being told to combine these terms. Which ones were alike could be simplified or reduced to smaller pieces. So negative x plus 4x plus negative 2x. You see the plus sign, I can just put this one or any of the other ones there. I'm being told to combine these, and that ends up being a positive 1x. If you want to put the 1 in there, that is more than fine. If you want to rewrite it with the variable first, you may absolutely do that as well.
Yeah, but where did the plus sign in between them come from?
From the problem.
What?
The problem, Luke, they've all got signs between them. All I did was change the negative, or the minus sign to plus negative. Okay? But the plus sign is already there. If there was no sign, we would be multiplying.
Is it invisible?
No. It's already there. All right. So, let's take it a slightly different direction. What are we on, example 5 now? Okay. Now, here's where things get a little strange. They can, but they don't have to. So we got to think about something, okay? X, the way we started out, we would assign some shape to X. Any term that had just an X in it. So we'll do circles for anything that has just an X with it.
That is just
But the 6xy, we got to think about something.
Six X's and Y.
how can it be X and Y? How do you?
Because log.
All right. So let's just suppose. Let's suppose that X equals
Y.
3 and Y equals 5. Okay?
So how do you combine that? You just put 6 for both of them?
Wait, what does 6xy mean? 6
for both of them.
times x and that times y. When you slap multiple things together in math, they're just a straight across multiplication.
What if X equals Y?
If x equaled y, then it would be simpler. But we don't know that, and that's the purpose for using two different letters, is that they're potentially different values. Again, the reason for using a variable is that it represents a quantity that we don't know the value of yet. Or a variable meaning a quantity that can change. So, if x was 3 and y was 5, then I'd have 2 times 3 minus 3 times 5 plus 4 minus 3 plus 4 times 5 minus 6 times 3 times 5. Now, again, the reason I'm doing this is just one, it's really long and not the best way. You think it's easier? It's easier to see when it's a number?
Yeah, you should do it all. Get change.
So, what I'll do, I'm going to highlight these. But I'm not going to highlight this one. Huh?
Because it's X and
It's multiplying the 5, it's x and y. It's got more going on. This term is not going to be alike with these two because it has an additional variable. Okay? So, I can't put a circle around it. That's pretty much just going to be separate, right? Basically, what people use this type of thinking to do is to prove to themselves, well, do I combine this with these x's or not? And the question I'll ask you to clarify is, well, if you do combine these with the x's, what in the world do you do with the y? Well, the y is a totally different letter. And absolutely not like with x. So,
take the X and the Y off and stuff, and then at the end,
Yeah, just do them
be
differently.
like
So-
X, Y.
all right, well let's try that. What do you think we should do, Autumn?
Just do all the rest of it, pretending that the X and the Y aren't there.
Just forget about it for right now?
Not the 6, but the X, Y.
But the 6 would be totally different if it didn't have the x and y, right?
Yes, you gotta forget about the 6 too.
Okay, you want to just cover it up for right now?
Yeah, and then just put it at the end.
Okay, sure. So we can say 2x minus x. What's that?
What? Oh, it's 1x.
That's just 1x. Sure, that's 1x. And then negative 3y. Can that combine with a 4?
No,
No, but it can combine with a 4y.
it's 1y.
That's plus 1y. Okay, so because it's positive, again, Luke was asking, why do you put a plus sign there? Because the signs are already there. You just have to put the correct one based on the result of your terms being combined. So since a negative 3 plus 4 ended up being positive, we're going to put a plus 1y. You know, I can do a triangle over that one if you guys want. This 4, what do I do there?
Just put at the end.
Put it at it doesn't have any friends to play with. Okay, sure. It's not compatible with any other dance partner.
It's random. That's the
So, now we'll take Autumn's advice. We'll bring the minus 6xy back. Right? I think that's a good strategy when there's a piece of a problem you don't quite understand it. There's the rest of it that you can do. Now, x plus y plus 4 minus 6xy. Yes, sir.
Because 6 has x and y, you could just subtract it. 1x and 1y.
But it's 6 x's.
Couldn't you just subtract?
But it's 6 of them.
Yeah, so subtract 1, or subtract, subtract.
Okay,
6 and 1.
okay. Separate them. What do you mean?
Do like, oh no, I will mess it up.
What does the order of operations tell us we have to do first? Multiply, add, or subtract?
Multiply.
multiply. So we have to figure out what this product is before we can add or subtract it to something over here.
But that is
Guess what?
the simplest you can get.
This is it. Because this requires multiplication, and multiplication by order of operations must take place before combining, you're done. XY is not a like term to X, and it's not a like term to Y for multiple reasons, but the simplest one I'm giving you is order of operations. You got to multiply first. You can't subtract before you multiply. So because of that reason, we can declare that 6xy is not a like term to x or y. And this would be the answer. Yes, ma'am?
If you have the numbers, why don't you input and then just multiply?
Well, you do. This was hypothetical. I started out this way, and I decided it's not going to be helpful.
That was, I feel like I understand the way when you did like the X.
Well, this is an old skill, right? We're just figuring out, but when I realized it doesn't really make it easier to understand why some things can combine and some things can't. The way your book describes it, it says 5 threes plus 4 threes equals 9 threes. Or you could say apples and oranges if you want to go on a popular comparison.
I just like squares and triangles.
Yeah, all right, if you like the shapes, go with the shapes. All right, let's do one more example here, and then we'll get rolling with what we're going to talk about on the next lesson, okay? It will be the gist of all of it. Variables on both sides. Okay, so example 6. X squared minus 3x plus 5 plus... Because we're extending quite far. I want you to be prepared for the delta math, that's why. Bless you.
Delta math.
Can you move the camera down, please?
I'm going. I want to write it first. All right. So, I don't think I've ever taught it the way I just taught it, but it makes so much sense now when we talk about order of operations. So, let's think about something. You want me to use colors or shapes?
Shapes.
Okay, shapes it is.
Let's
Right, if you don't vote, you don't have an opinion, I guess. So, I can use both eventually. So what I want to do, I want to go through and make a common shape around like terms. So for x squared, we can make that square. I think that makes sense, right? Is there any other term that I could go and say will be combinable?
4x squared.
4x squared. Okay, Luke, how'd you spot that?
3x and 8x.
All right, well, let's think just a second. These x's have exponents.
But they have X too.
This one has an x, but it's not squared.
So let's put a triangle around it.
Okay, so what I want to make sure you're clear on is these two terms cannot be combined. And the reasoning I'll give you is order of operations. That, okay, how would you combine them anyway?
Because
By minus subtract. Make it negative 2x to the power.
you just said you can't combine them.
You can't.
Would.
So why would you ask how you combine them?
Well, I'm curious what some of the misconceptions are. I'll get to that in a second. Pardon my misstep there, Luke. But these are the only ones that have x squared. I can't combine with the 3x because these have exponents, which comes before multiplication. So I have to compute what that is.
An exponent.
Root on order of operations goes yes.
I think that's right, what you're saying. I'm not sure what you mean by that, but I think so.
Exponent and then yeah.
So we can put a triangle around that one.
You said up
Anything else?
8x.
The 8x, okay. And then we can put a circle around the constants. Okay? So really that's all this lesson is about.
Shapes.
Being understanding what can be combined and simplifying it. So I have x squared plus 4x squared.
We're gonna go in.
5 squared. 5x squared.
5x squared. So Quentin, how did you know it was 5?
Because 1 plus 4.
There's an understood 1 here. Okay? Shh, Luke. Shh, shh, shh. So there's an understood 1. So I can go ahead and combine those and make a 5x squared. What can I do next? I can combine the triangles, right? I have negative 3x plus 8x.
5x.
5x.
Okay, so what do I put here?
Plus.
Plus. Why plus and not minus?
Because you can add as many plus signs as you want.
Well, the result of these combined terms was a positive. So remember, the signs are already there. Whether it's positive or negative indicates what sign you put here. And then I have 5 and negative 8. When you combine those, you get a minus 3. We're done.
Oh, that's the end?
In addition sign.
You could, and then if the outcome was negative, you could put plus negative. You can consolidate it or shrink it by just putting minus if it ends up being what. But yes, you could always put a plus sign. And that is why, again, why I called this combining like terms at the beginning.
Could you put the negative 3 first and add it?
You could. You could say negative 3 plus these, Madison. Sure. I'm going to go ahead and clue you in on something, though. You're going to learn something called standard form next year. And standard form requires that you write it this way. You start with the variable that has the highest exponent, and you work your way in descending order. And the constant comes last. Okay?
Yes.
Constant comes last, sure.
That's one to fail.
Cold.
All right. Why do we have to learn how to combine like terms? Because we're going to have to solve equations that have like terms that must be combined before we can solve them. Okay?
What's
So,
STD stand for?
standard does not stand for that.
Wait a minute.
Okay. Everybody gets a kick out of that. So, and then 96 is multiple term equations. So, variables on both sides. Maybe we should we do? Nah, we won't do that. All right. So variables on both sides. So let's write an example of an equation that we know how to solve. A two-step equation. So can you guys help me out there? We don't have to do it that way. We're just going to do a simple two-step where you have to add or subtract the constant and then divide. So 3x minus 11 equals 34. Okay? All right, and that's pretty straightforward. Can I clue you guys in on something? You've already been combining like terms and you didn't know it.
Really?
The 11 and the 34 are both constants, right?
Mm-hmm.
And the first step towards solving this problem is to add the 11, right?
Right.
Now we didn't say that we were combining like terms there because I didn't want to confuse you, but
You always add.
since both of those are constants, we're going to combine them into one location. Now we saw a different purpose for that, right? It does make it simpler, but I want to make sure everybody's clear. You're combining like terms when you add 11 to both sides. Why did we have to add, though? I was moving the 11 to the opposite side of the equal sign, so I've got to do the opposite operation. Does everybody hear that?
Mm-hmm.
I had to move it to the opposite side. I had to do the opposite operation. Keep that simple idea in mind. So what happens, we end up with 3x here equals 45.
Divided by 3.
All right, so now it should be like almost mechanical, like automatic. Just divide both sides, you're going to get x equals 15. Okay?
These are easy for me.
These aren't too bad? Okay, so let's just change it just a little bit.
Just a little bit.
Okay?
Sounds more difficult.
I'm glad that these are easy. I hope that these are getting even easier every day. But 3x minus 11 equals 34 plus 2x. Oh, shish kebabs.
What's a shish kebab?
It's like a skewer with meat and vegetables. Okay, kebab. Shish kebab's the long word. All right. So, you guys see how close it is? Is it still going to be okay if we add 11?
Yeah.
Yes.
Why? Why is that still okay?
Because it's still constant.
All right, I'm still combining the constants. Guess what? You can move everything to whatever side you wanted. And I'll go over that in a second. But for the sake of simplicity and to make sure it's consistent with the last problem, I want to add 11 to both sides. What that's going to do is get all my constants on what side?
On that side.
Right side.
On the right side.
That side.
Not necessarily the correct side, but the right side. So we know that's going to cancel, just like it did up there, and I'm going to have 3x equals 45 plus 2x. Now, do you realize that 3x and 2x are like terms?
Yes, I did. Yes.
So what should I do with the like terms?
Combine them.
All right, I should combine them. But they're on opposite sides of the equal sign, so how am I supposed to combine them?
Switch cross them out.
You gotta divide it. You gotta move the
Could you divide?
All right, so Autumn, you want to move the 2x. How do you propose we do that?
Move it.
Well, look at how we move the 11.
Add it on both sides of the equal
Okay,
side.
okay. Luke, if I add it, is it going to cancel out?
You subtract it on both sides of the equal sign.
But you were right when you said do this on both sides. Now, if I want to move it to the other side, I have to use the opposite operation. So I'm going to do it, subtract on both sides. Now, again, make sure you see, I'm combining like terms in this step, but I'm doing it on opposite sides of the equal sign, so I use the opposite operation. What happens over here?
Cross them
Comes zero.
out.
Cross them out, and 3x take away 2x gives us,
1x. Okay, just
and then 45
1x.
is just there. It's the answer, actually, because we're done.
Isn't that a 3-step
This is a
question?
little confusing.
Sure.
Haven't we done this before?
It's actually just 2, but
Well, it's
no, we haven't done it quite like this before.
We've done this before.
We've done like example 1. What do you mean the same thing? It's a different answer. Different problem.
Yeah, but
What's the matter with y'all?
Anna said that the time was 1:22.
Okay.
No,
All right. Question back there? So let's do a couple more and we'll finish up.
Can I have that? Thanks.
So what we got? Lesson 95 continued. Okay? All right. So example 3. We're on example 3 for lesson 95. And we got to focus.
With what?
10 minus 8x equals 11 plus 9x. Oh, that one's not going to be good, is it?
Shish kebab.
Let's make this, hang on.
8x.
Do what?
Can you make it 8x?
Can I make what 8x?
No.
No. No. We can make this,
9 eggs.
All right, we just leave it like it is, because look, all the problems aren't going to work out to pretty answers anyway. Okay, so what do you notice over here? And to be honest, I could go ahead and just teach lesson 96 if y'all wanted me to, because it's no different. You already know how to do it.
Oh.
Easy there. Okay, so I've got to combine like terms. My first order of business should always be combine like terms. We don't do, I don't think we do, equations with distribution in this class. Oh, but we didn't get to it. Maybe we should, but
No, we shouldn't.
yeah, we'll do that on
No, we
Thursday.
shouldn't.
All right, 2. I'll just stop there. Combine like terms. That's what we want to do. So here's the choice. A lot of people don't like this. You can choose to move all the x's to the left or to the right.
I don't like
But if you choose to move them to the right, you should move the constants to the left. If you choose to move the x's to the left, move the constants to the right. It's
What if we go-
logical thinking that you want to get the x's in one place and the numbers the other side.
Why don't you just do it like it is?
Yeah, it's totally okay to do it either way. So I prefer to keep my variables coefficient. Wait, what's a coefficient?
Coefficient is the number before the variable.
It's the number before the variable. It's the number that's multiplying it. Good. So I have negative 8x over here. I have positive 9x over here. If I add the 8x, everything will stay positive. So I'm going to do that. I'm going to add the 8x. Now again, what am I doing? I'm combining like terms. Where? On opposite sides, so they require the opposite operation. The other logic for that is that it will cancel on this side. So I'll be left with a 10 equals 11 plus 17x. Now what do I do? Finley, can you tell me how I can get to the next step? Not sure? Well, I combine like terms with the x's. Now I've got to combine like terms with the 10 and the 11.
Subtract.
Subtract what?
You gotta subtract the 17x from each side. 17.
What's that going to do?
Negative 17.
It's going to cancel over here. It'll just move it over here, though. But I don't want to do that because I just moved the x over here.
Subtract the 11.
So if I subtract the 11, 11 and 10 are like terms. Those go together. It cancels over here, and you notice now, Anna, that the x is only got a 17 attached to it, and there's nothing else over here, so that's good. That's progress. And then 10 minus 11 is negative 1. Last step.
Divide by negative 1.
No.
17.
Divide by 17. Remember, the goal of this problem is to get x equals and then an answer. So, if I divide by 17, I get my x. I got to do it on both sides. Now, here's why I said, oh, it might not work out pretty. We're done. We can leave the answer as negative 1/17 and be golden.
Wait, we can?
Yeah, you're done.
Okay.
It's 0.06.
No, it's negative 1/17.
Okay.
Just kidding. Okay, so I told you at the beginning you could have done it the other way. You could move everything to the other side instead. So instead of moving the 8x over here, what I'm going to do, you only have to do it one way, so you don't have to write this unless you want to. I'm going to move the 9x over here. How am I going to do that? I'm going to subtract it. So I'll get 10, and then I have negative 8 minus 9x. Negative 17x, and then I've got my 11 over here. Now, how am I going to move the 10? I would subtract it. Again, you don't have to write this. This is just the other way to do it if you moved it to the left. My purpose in showing you this is for you to see that it didn't matter. It will cancel there, and I've got negative 17x equals 11 minus 10 is 1. Final step is to divide by negative 17. And you get x equals negative 1/17. The same answer. So, I think that's the reflexive property is that A equals B, therefore you can say that B equals A. It doesn't matter where you move everything to the left or the right. Yes?
Why is the negative on the 1 and now on the 17?
Because negative 1 over 17 is equal to 1 over negative 17, which is equal to negative 1 over 17. The negative doesn't matter where you place it because the outcome is negative. Now, if you put the negative on top and bottom, that would not be equal to those. Because that's equal to positive 1/17. All right? Longer answer than you wanted. We got about 4 minutes. So, I'm going to give you a preview of lesson 96. And then we'll do more of it in 2 days instead of 3. So, lesson 96 preview. Exclusive to AHA for all right, anyway. Okay, so here we go. All right, this looks hideous. I know you're like, oh, why do we have to do this? It's all about discipline and the properties and being able to consolidate things, okay? So, you'll notice I only have 2 types of terms. I have terms with x and I have constant terms. So, the first thing we should do, kind of like Autumn suggested in a previous problem, forget about one side and work one side at a time. So if I work on that side first, what do I need to do? I need to combine some like terms.
2x and 3x.
Huh? Sure, it is. That's exactly what it is. So 2x and the negative 3x, what would that combine to become? Negative 1x, right? 2 minus 3 is negative 1. The x just slaps on because that's what establishes the term. And then I have 5 plus 8, positive 13. Okay, so these 4 terms broke down into 2 simpler ones. Okay, now I want to work this side. X plus 4 minus 5x.
Okay, 6x plus 4?
No.
No, negative 6x, negative
Huh?
4x, negative 4x.
1 minus 5x would be a negative 4x, and then the plus 4 would just come down. Yeah, but you said it after like 2 or 3 other things.
It'd be x. It'd be x because you mix up the negative and
No.
positive.
These are not like terms, so these can't be combined. Here's one reasoning I gave you today, is that this has multiplication attached to it. You have to multiply before you add, so you're stuck here. Does everybody get that?
No.
Order of operations says you can't combine those. I'm so proud of you. All right. Now, look at where we're at. Now we have a simplified expression over here. Simplify means to combine your like terms as much as possible. That's done. That's done. But now I can start working on opposite sides to combine like terms, so I'll need to use the opposite operation. Here's where you get to choose. Do you want your x's on the left or the right?
The ref.
Doesn't care as long as I don't dance with them. Okay, so... Okay, how do I do that then, Autumn?
Subtract 4 on both sides.
No. Oh, wait, what?
Subtract 4 on both sides.
Oh, you want to do that?
Yeah.
Subtract 4, so subtract 4. She said subtract 4, so I just did the 4 here. You knew that subtract would work because it was originally being added, so that goes away. And I have negative 1x 9. Is it positive or negative?
Positive.
It's positive, so I'll put plus. And then negative 4x is still chilling over here.
Now you divide.
You subtract negative.
I still have to get all my x's in one place before I can figure out what in the world it is. So now I add 1x. Okay, now I'm going to be completely transparent with you. When I first learned this in the 7th grade, I was terrible at it.
7th grade.
Yeah.
You were in 7th grade?
At one time in my life, yes, I was.
No way.
Okay, so this was a hard thing for me to learn. So I'm trying to make it as procedural as possible and make sure you know why we do each step that we do. Those crossed out, the 9 stayed put, and I have negative 4x plus x. Negative 3x. Now it's a one-step equation.
Okay, then
Divide by
negative 3.
negative 3. Remember, what we want over here is a 1x. So I want to divide by whatever's over there. So I'll get x equals negative 3. So that's a preview for 96. I'm going to add in one other thing to wrap this year up, because you guys did pretty well with this. Okay?
You did?
Yeah.